Students, welcome all of you in online lecture series of Internet of Things subject, in which today we are going to discuss the topic that is interfacing with analog and digital sensors, in which today we are going to see the different devices, that is temperature sensor, analog to digital converter or digital to analog converter, then what are the programs. So this is all about we will study in this lecture. So today is our 16th lecture on this subject. My name is Pooja Subhashrao Deshmukh from International Center of Excellence in Engineering and Management College, Aurangabad. So in last lecture we have studied that Arduino interfacing, or there is one example, that is LED blinking with installing on core Windows operating system. What are the development platforms of Arduino IDE? Then what is the pin diagram of Node MCU? Then serial communication, what are the onboard LED indicators, switches. So this is all about we already studied in last lecture. Now in this lecture we are going to study LM35 interfacing. This is the temperature sensor with Node MCU. Then interfacing diagram of this. Then the Lua script for LM35. Lua script is nothing but a programming language in which we write a program for our Node MCU temperature sensor. Then Arduino sketch for LM35. ESP8266 ADC, that is analog to digital converter. Node MCU, this is the analog input, and ADC in ESP8266 Node MCU. Then demonstration for the ADC by using Node MCU, then the circuit diagram of that, and we write a code for this, and what is the output of this. So the all points we will cover in this lecture. So let's get started one by one. First of all, LM35 interfacing with Node MCU. LM35 is nothing but a temperature sensor, as I told you. So this temperature sensor is used for the measurement of temperature in the range of -55 degrees Celsius to 150 degrees Celsius. Also, this is the 3-terminal device that provide an analog voltage proportion to the temperature. So the higher temperature, the higher is the output. Means what? This device, if we are giving higher temperature to this device, and same thing we will get the output in that range. So next one is output analog voltage, which is converted to form digital form using ADC. ADC is the analog to digital converter, so that a microprocessor can process it. Also, Node MCU ADC can be used to measure the analog voltage from LM35, that is temperature sensor, and temperature which is in proportion to the analog voltage. So this is all about LM35. This is the diagram, or this is the device which will you can see in the figure. This is the temperature sensor. The next one is interfacing diagram of temperature sensor and Node MCU. Here one example is given, that is LM35 output is given to the analog pin. Analog pin is A0 of Node MCU. Then this analog voltage which is converted to its digital form and processed to get the temperature reading. Then we can write codes for the Node MCU dev kit. Dev kit means what? Development kit, in either Lua script, C language or C++ language. So means what? If you want to write a program for the temperature sensor with Node MCU, you can write the program in these three languages, that is Lua script, C language and C++ language. Suppose we are using eExplorer IDE for the writing code in Lua scripts. eExplorer IDE is a tool for writing a program. So we are writing a code in Lua script and Arduino IDE for writing code in C and C++. Then what? This is the interfacing diagram. In figure you can see that there is a temperature sensor which is connected to A0 pin of Node MCU and one pin is connected to ground, and here plus 5 volt is supply which is connected to VCC. This is the interfacing diagram. Then we will see what is the Lua script for LM35. Lua script, as I told you, this is the programming language. Lua is a lightweight, high level, multi-paradigm programming language which is designed primarily for the embedded systems used applications or Internet of Things used applications. Lua is a cross-platform since the interpreter of compiled byte code is written in ANSI C. ANSI C is a book, and Lua has a relatively simple C API to embed it into the applications. So this is the Lua. So we will see what is the code. V reference is equals to 3.3. We are giving the input, that is 3.3, and the resolution of this is V reference, that is 1023, and analog voltage is equals to ADC dot read 0. If any analog voltage is greater than 1023, then what? This is the analog voltage which is equal to 103, and end of program. Then again, what is the temperature? Temperature is equals to analog voltage into resolution into 100. This is the formula for temperature, and it will print is what? LM35 temperature. This is the sensor which is reading temperature value. So this is the script for Lua. After applying this script in eExplorer, you will get the output in the form of, like you can see in the figure, there is do file lm35.lua is what? LM35 temperature. Temperature is what? 26.451612903226 in this manner. This is our output. Same we will see the Arduino sketch for the LM35. This is Lua script, but we will see Arduino sketch. First of all, float V reference is equals to 3.3. Float is means what? This is the type of number, that is which is writing in floating point. That is V reference is equals to 3.3. Then float resolution. Float resolution is what? V reference divided by 1023. Then void setup. Void is means what? Nothing. When we are writing a void keyword, then means what? We are writing nothing. Then serial begin, that is baud rate is 9600. Here we are defining a baud rate of serial communication, because we always use baud rate for the serial communication. Then void loop. In what? Float temperature is equals to analog read A0. Then temperature is equals to temperature into resolution. This is given, we know that. Then temperature is equals to temperature into 100. And serial dot print in means what? We are printing serial communication, that is in form of temperature. Or delay, we will get the delay after each iteration, that is 1000 millisecond, and closing the program. After you are giving Arduino sketch to the Node MCU, you will get the output in the form of, that is LM35 temperature, that is 50 2 and 84, 24.52, 24.84, then 24.84. So means what, after reading one value it will get 3 times 84, that is 24.84. Read this value 3 times. After that one time it will read 24.52. You can see in the figure, that is LM35. The next one is analog input model, that is ESP8266 ADC Node MCU analog input. In this figure you can see that in this manner we will interface this input model to our Node MCU. So we will see how can we interface this device. First of all, in this tutorial we will learn that how to use ADC peripheral of ESP8266 SoC and read some analog values. Also, for the demonstrations of this pin ESP8266 ADC, it will be using, that is Node MCU board, which is based on the ESP12E module. Also ESP01 doesn't have an ADC pin, we know that. That's why we are using this model, that is ESP12E module. First of all, introduction, that is analog to digital converter is simply ADC is an amazing features of the most modern microprocessors or SoCs. So an analog to digital converter is as the name suggests, it converts continuous analog signal into its discrete analog values. So this is really important to all the microprocessors are digital devices and work only on logic low or logic high values, means what, 0 and 1. This is the form of binary. So in this manner it will works. ADCs allow microprocessors and SoCs to interface with the analog devices, like means what, sensor, like a temperature sensor, or it build systems around them. So what are these? Most modern microprocessors already have an ADC block to build into their silicon. So you don't need to use an external or dedicated ADC IC. This is the main advantage of this. So we will see next one, that is ADC in ESP8266 SoC. This is what the ESP8266 EX SoC, which is the main processor in all the ESP8266 board. Also it has a single channel ADC, and the ADC 8255 ESP8266 has 10-bit resolution, and this is a successive approximation register, which is also SAR type, SAR. SAR means successive approximation register. So the 10-bit resolution means what? Output values will be in the range of 0 to 1023. So if you refer the data sheet of the ESP8266 EX model, that is SoC, the ADC pin is the pin number 6, which is known as a T-out pin. And the ADC can be used for basically of two type of measurement. By using the ADC we can measure in these two types, that is measure the power supply voltage at pin number 3 or pin number 4, and if you want to measure the input voltage you have to use pin number 6 or pin number T out, which is also known as pin number 6 or which is also known as pin number T out. So both the measurements can be implemented at the same time. For the power supply voltage measurement, T out pin is must be left floating means what? In the there are some points, that is 0.123 something or 0.25 something, in this manner. But when measuring external voltage, that is at T out pin, the input voltage range should be between 0 and 1. There is no floating point, there is only integer type. So 0 volt and 1 volt. If you are building the firmware from the SDK, then refer to the data sheet and other relevant documentations, as there is a lot of information which is related to ADC and its configurations or its pin configurations. So all this information in the data sheet. The next one is ADC ESP01. Here you can see in the figure that this module is ADC ESP01. If you don't have a vanilla ESP8266 board, that is ESP01, then you are out of luck, that it doesn't have the pin for the ADC on the board. So if you are desperate, then you can use pin number 6 as a ADC pin. But if you have to remember that it can accept voltage in the range of 0 volt and 1 volt only. Means the large voltage you cannot use by using this pin. Otherwise your device will get damaged or it will not work properly. So you have to just take care for this. Then next one is ADC ESP8266 Node MCU, in which the Node MCU board, which is essentially based on the ESP12E Wi-Fi module. This module we have already studied in last lecture. So it has the pin for the ADC, which is called as A0 pin. So additionally, Node MCU also take care the input voltage range limit from the 0 volt and 1 volt. For more user friendly, it will take 0 to 3.3 volt for the A0 pin only. Here you can see in the figure, that is A0 pin having the voltage 0 volt to 3.3 volt. The next one is, there is some important note for you, that is, if you take a look for the schematic of Node MCU, the ADC 0 pin in next figure, that is there are two registers and T out pin is connected. In this figure, ADC 0 pin in the above pin out image act as a input to the voltage divider, which is formed by 220 kilo ohm and 100 kilo ohm resistors with the output of the voltage divider, which is given to the T out pin of ESP8266 EX SOC model or SOC pin. So the voltage range of ADC is 0 to 1 volt. We know that. If you want to use ADC for the 0 to 3 volt, then you have to use the voltage divider circuit, means this circuit you can see in the figure. So ESP01 users, you don't have access to pin ADC, then it can solder a wire to pin number 6 of ESP8266 EX SOC, and then you can use it with the voltage divider. But the warning is that you do not provide more than 1 volt directly to the ADC pin, that is pin number T out or pin number 6 of ESP8266 model. So this is all about configurations. The next one is demonstration of 8266 ADC using Node MCU. Suppose if you have a ESP8266 Node MCU board and you can directly use the ADC pin, that is A0 pin, for reading analog voltages in the range of 0 volt to 3 volt. Then let us now build a small circuit circuit for the demonstration of ADC function. Here suppose one example is here, that is 10 kilo ohm potentiometer is chosen as analog input device with its end terminals and connected to 3.3 volt and ground, and the wiper terminal which is connected to A0 pin, as you can see in the figure of Node MCU. Then the analog voltage is converted to digital values and displayed on the serial monitor. So for that we have to require some components, that is ESP8266 Node MCU board, then 10 kilo ohm potentiometer, then one breadboard and some connecting wires. Here circuit diagram is shown for this demonstration, that is here this is the circuit diagram. Node MCU board and which is connected to 10 kilo ohm resistor through 3.3 volt input and connected to ground. So we write a code for this, that is before proceeding with the code, I strongly recommended that you go through the getting started with the Node MCU tutorial, or it has the necessary information for setting up the Arduino IDE to use with the Node MCU board. So this topic already we have studied in last lecture. So please keep in mind, or please go through it once and then you can write down this. So first of all we define analog input signal, that is hash define analog pin A0. We are giving input to A0 pin, or ESP8266 analog pin ADC is equals to what? A0. ADC is equals to A0. Then int ADC value is what? 0, because ADC is equals to A0 means what? ADC value is 0. This is the variable to store the output of ADC. Then void setup. Void setup is what? Null, because in this we are not writing any value. Then open brace serial dot begin. Here we are initialize communication in serial form with baud rate, that is 1,15,200. Here we are initializing serial communication at this baud rate range. Then close brace. Again we go through the loop, that is void loop. Open brace ADC value. ADC value is what? Which is equal to analog read of analog pin. Analog pin is A0. So the read the analog input value here. Then print whatever we printing, print the output in the serial monitor, that is serial dot print ADC value is equals to, ADC value is what? Serial dot print in ADC value. Again we are here getting some delay, that is 1000 millisecond delay, and process at output. So in this way we are writing the program. After writing this program or given this program, we will get the output in this format, that is ADC value is equal to 278, ADC value is equals to 278, then 281, 357. So in this manner you will get the serial output of this ADC module. So this is all about interfacing with different analog or digital devices. I hope you all understand this interfacing devices. If you have any query, you can contact me anytime. So thank you very much. Have a good day.